Okay, so you will remember that yesterday we were talking about collision. We were talking about collision yesterday, and remember the whole idea is that the initial momentum is equal to the final momentum. And sometimes there is momentum, sometimes there isn't, which is what we're going to look at soon. So here we have, this says linear collision, one thing at rest. Okay? So we got a 4 kilogram ball moving at 4 meters per second east, strikes another 2 kilogram ball at rest. If the final velocity of the 4 kilogram ball is 2 meters east, find the final velocity of the smaller mass. Oh, did we do this? Did we talk about elastic collisions?
Yeah.
Yeah, we did, right?
Really quickly.
Really quickly. Right, we did. Okay. Okay, so should we label these like A and B or something other?
Yeah.
A and B tends to work better than 1 and 2 because once you start throwing 1 and 2 and then it's another number and it can get confusing, right? So let's go with A and B. So we'll call this one A and the one at rest is B. Right? If the final velocity of the 4 kilogram ball is 2 meters east, find the velocity of the smaller mass. Okay, so the smaller one would be the B one, right? Okay, so let's start with PI is equal to PF. The initial momentum, the momentum before the collision is equal to the momentum after the collision. Okay, that's the framework that you always start with. And the initial momentum is made up of, now if you want, you can write PA plus PB if you want, or you can just skip right down a step and write MAVA plus MBVB, right? The mass of ball A times the velocity of ball A plus the mass of ball B plus the velocity of ball B. Now, have you given any thought to how you like doing these? Do you want me to do the whole left side, or do you want me to do both sides at the same time?
Both sides. Left side. That's fine.
How many? It's okay. I can do it both ways. How many people like both at the same time? It's just kind of interesting for me to find out. How many people like one side and then the other? So it's about 50-50, which isn't overly surprising. So I've started this one to do just left side, and then I'll do the next one the other way. Okay? You can do it either way. It's up to you. So MAVA, that's going to be mass of A is 4, and velocity A is 4 meters per second east. Is the east important? Yes, it is. Because it's positive. Mass of B is 2, but it's at rest, so it's 0. Right, now you should be able to do those steps. Do you really need to write 4 times 4 is 8 plus 0? It's like, you're right, it's not.
So, yes. I made the exact same mistake.
Did you?
I got 8, then I erased it and put 16.
So 16, right? Okay, put your equals there. Okay, so now PF, that's going to be MA VA. Now, how did we do that thing before?
I thought it was MA plus PB.
Oh, remember, you only add the masses when after they're like together, right? Remember, there's elastic, which is, and then there's inelastic, which is.
So what are we doing right now?
So does it say anything about them sticking together?
No.
No. So they're apart.
If they're together, it's going to say.
It'll have to say they remain together, or it's something where it's obvious, like a football player catches a ball or something like somewhere.
Obviously, they're stuck together.
Yes.
Yeah. Okay.
Okay, so this is going to be MAVA plus MBVB, and we came up with a new convention to denote the velocities after the collision. We use that prime thing, right?
So now, if they don't say
Yep.
stick together, you do
Yes, then you keep them separate. Well, they're still separate masses, right? This is one ball, and this is the second ball, and they are separate. Right? They're separate. Now, is the mass of A before the collision the same as the mass of A after the collision? Yes, of course they're the same, right? So those are going to both be 4, right? And this is going to be 2, right? The masses are the same. And the velocity of A, now here, if the final velocity of the 4 kilogram ball is 2 east, so this is now a 2, and you're solving for VB prime. So now we're going to have 8 plus 2 VB prime. Can you solve that all in one step? grade 12 students should be able to. VB prime is, the 8 goes to the other side, becomes negative. So 16 minus 8, and then you're going to divide by 2, right? So that's going to be 8 over 2, which is 4 meters per second. Now, is it at all surprising that if the one that was moving 4 and is twice as big then becomes cut in half, that the other one now goes 4? Shouldn't be, right? Is the total momentum before and after equal? 16 on the left, 8 plus 2 times 4 is 8, 8 plus 8 is 16, right? Momentum is conserved, equal. We say conserved.
So then, like, technically, you wouldn't even have to do all the steps. You just do the second step and then do it in your head.
I guess. Some people like to do it, like, not only do the two sides, like, some people like to do this all in one step. They find out what the PI is, and then they do a whole nother sort of step with PF equals that, and then, like, sort of separate them two completely. Do you know what I mean?
I do, yeah.
If you want to do that too, you can. Okay, now, does it matter if they're both moving in the same direction? All that matters is they're both positive, right? No big deal. One was that, the last one, the one was at rest. So again, let's go with A and B, and this time I'll do them simultaneously. So PI is equal to PF. Do you have to write that every time?
Yes. I like it.
You don't have to, but it
That's a starting.
is. It's a starting. It literally starts you with everything. You don't have to, but it sure helps your thinking. Okay, so what makes up PI? Mass of A times velocity A plus mass of B times velocity B. Now this time I'm going to do them simultaneously, right? So mass of A times velocity A prime plus mass of B times velocity B prime. Now you got to be careful. You got to sort of take your time and make sure you get it right? Because it can get pretty confusing after a while. Okay, so let's plug in what we know. Mass of A is 6. Whoopsie. Mass of A is 6. Velocity A is 4. There's a lot of numbers floating around here, so be careful. Mass of B is 2. Velocity B is going 3. It's also east, so that's to the right. The final velocity for the 6 kilogram ball is 2 east, so that's going to be 6 times 2. Oh, here's another tip. If you went A and B, and most students are going to go A and B here, go A and B here as well, right? Like you can see this mass and that mass are the same, right? Do it in the same order is what I'm saying, right? I mean, you're likely going to do that, but... Okay, now mass of B, 2 VB prime, right? Now, is it always going to be the second one that you're missing here? Not always, so be careful. But really, what's different here? The only difference is that before I had a 0 there, right? Ooh, now you got to multiply 2 by 3. So 24 plus 6 is equal to 12 plus 2 VB prime. Can you do that all in one step? I would hope grade 12 students can do that. VB prime is going to be 24 plus 6 minus 12 all over 2. 24 plus 6 is 30. Minus 12 is 18. Divided by 2 is 9. These aren't that bad, really, are they? Now, if I had shown that to you, say, like the second month of grade 11, you would have run for the door. Right?
Yeah.
So think about how far you've come since then.
Yeah, but this is literally take the numbers and fill it.
I understand that, but literally, if I showed you that in grade 11, you all would have freaked. I should show it to them in grade 11?
Yeah, you should show them math more. So what do you think?
Just give
I don't want them to quit physics. I need a job.
you like a pop quiz and be like,
Do you want to try one? This one is opposite direction. What's the only difference?
It'll be negative.
Try it. You can do it. Go look it up, I guess.
What a beauty.
Because it strikes that ball from the second half. And then it's like the ball the velocity's 5. So it's moving east. No, west.
So far, so good?
Yeah. And then the other guy.
Minus 27 on the left-hand side?
Yes.
I like to, on the right-hand side, I like to just go like, and just put those masses in right away so that I know that I've got them right. Like I like to, because I see that 1 and 6, I put the 1 and 6 there first before I even deal with the velocities. I put the masses in the same order. Right? So now the A ball, the 1 kilogram ball, because then sometimes it says this, right? You can match it up easier. 9, that's west, so that's going to be minus 9. And this is going to be VB prime, right? Oops. Minus 27 plus 9 divided by 6, right? So that's minus 18. So is it minus 3? Is it always going to be nice integers like that? Okay, now normally, see, I would have liked to have done that the other day. You should have this one. Do you have this one? It says explosions and momentum.
So momentum and equations are.
That's all that. Those problems are both of these. Yeah. No, you should have this one with the cannon on it. It says explosions and momentum. Do you have that? Okay, so explosions are really just a collision in reverse.
Oh.
Right? Like if you think about, that's a collision, that's an explosion. It's just in reverse. And the theory is exactly the same. Common examples of the conservation of momentum center around 2 or more objects colliding in the atoms of external forces. Another twist on the example of a collision would be the idea of a reverse collision or an explosion. If you videotape such a dated phrase, if you tape an explosion, people still say tape even though you're using your phone, right?
I say
Although,
record.
yeah, kids tend to say recorder. I've noticed that people don't say tape as much as they used to. It looks like a collision. Likewise, if you videotape a collision and play it backwards, it resembles an explosion. If you look at the case of a cannon being fired, we find there is a force of the gunpowder exploding, creating a force on the cannon, pushing on the cannonball, and the cannonball pushing back on the gun. These two forces are equal in size but opposite direction, Newton's law. If any forces that are external to the cannonball system, such as weight and friction, are removed, then momentum must be conserved. Now this symbol right here, see what that says right there? That funny-looking E thing? That is the Greek letter sigma, and in stats it means the sum of.
Finally pronounced correct.
Alpha, beta, gamma, I haven't been pronouncing right. How do you pronounce alpha?
Alpha's right.
Oh, beta? Oh, also, it's like French and Spanish for the Spanish for the. Oh, but in Spanish the V sounds like a B, so you're saying the V sounds like a V. Oh, that's weird. For me.
No, it is.
Anyways, without getting devolving into my ability to read Greek, that is the Greek letter sigma, and it means the sum of. So this means the sum of all the momentum is equal to 0. Huh? His mother's Greek. Yeah. The letters are the same in French. Yeah. Just whatever.
What letter is that then?
That's an E, I think. Am I right, Josh? Or equivalent to an E? Sigma? Or is it an S?
It's the S.
Yeah, it's the S, I think, yeah. As soon as I said it, no, that's wrong. E is epsilon, I think. Yeah.
What is life?
That's such a cool word.
It is a long word. You're right.
And E for them is
Epsilon.
Yeah, but like when they write that, like sigma, like is the spelling of sigma?
I don't know. It's a letter. It's like the letter. Like how do you spell the letter J?
Yeah,
It's
but
spelled W.
J!
it's not sigma.
It's not J-A-Y.
Yeah, A only has
Okay, you know what you're doing now? You're zooming in on India.
How do you spell W?
W.
Double U. Ah, you got me.
What?
He asked how do you spell W.
What you use?
You.
Why is it not called double V?
D-O-U-B-L-E.
French is double V.
Is it?
Duplicate.
Oh yeah, duplicate, right?
What's that?
Anyways, you guys are zooming in on India again here. Okay, stop. In the example at the left, the external forces have been removed by placing the cannon on a frictionless surface. In the beginning, both the cannon and the ball are at rest. As a result, the total momentum before the explosion is 0. So in fact, explosions are actually easier than collisions because the momentum at the start is 0. The whole left side is just 0. Right? It's easy. Since the total momentum of an isolated system, meaning no external force is conserved, then the total momentum after the explosion would also be 0. Christine, you should watch and not put your phone down. Mathematically, it looks like this. Now, this looks complicated, but it's not that bad. Sigma p, that just means the sum of all the momentum. This is really just what? Pi is equal to Pf. That's just another way of saying that. Sum of all the initial momentum is equal to the sum of all the momentums prime after. That's all that is. No, I wouldn't use it. It's just their way of describing it. I wouldn't use it. So here we've got P cannon plus P ball is equal to P cannon plus P ball. But notice that everything on the left, they do all the math, but everything equals 0. And everything, that means everything over here. Yeah, you should, right? Yeah, you should. Okay, let's go straight to the, do you have this question at the bottom of your page? You should have this at the bottom of the first page, right? Second page, yeah. Okay, on the back. Suppose in the example the 5 kilogram cannonball moves with a speed of 25 meters per second. After the explosion, how fast will the 100 kilogram cannon itself move backwards? So let's start with Pi is equal to Pf. Now if you want, you can do all that stuff over on the left, but what's it going to equal?
0.
Do you want to just put 0?
What?
Well, okay. What if, here's a question for you. What if the cannon is mounted on a moving object? And then,
But it would say that it's going to be 0.
could you do it this way? Let's say the whole cart is moving at, we'll say, 5 meters per second. Okay. The whole cart is moving 5 meters per second, and then over here goes, and this thing comes shooting out. Could you just do it as if it was at 0, and then at the very end just at 5? Would that work? Absolutely.
No, you're all wrong.
Why don't you just put a 5 there?
I don't like that. I don't understand why you just add a 5.
Well, if the whole thing is moving at 5 meters per second to begin with, and then the ball is fired, right? So it has its velocity because of the explosion, plus it has its original 5 to begin with, right? It's like me doing this, and I think I did this with my grade 11s.
Velocity from the explosion equals 0, but the moving from the car is 5.
Right. Like if I'm walking here and I drop the ball, does the ball fall straight down?
No.
Or does it like kind of curve? Riley's about the only one that's going to get a good view of it because they're going to drop it right about there. So as I walk like this,
Yeah,
it goes like this, right?
Yeah.
Right? Like it doesn't drop straight down. It's really just vector addition, right?
Where's the creek?
Okay. So, anyways, that was a little bit more than we needed to. So let's put just 0 there, right? Okay, so we're going to say mass of cannon, velocity cannon, plus mass of ball, velocity ball. Do I need to do the primes here?
No.
You don't need to because there's nothing on the left, but is it a good habit to get into? Probably. And you're probably going to do it anyway, just out of force of habit. Okay, so the 5 kilogram cannonball moves with a speed of 25. Now that was to the, remind me of the picture?
That way.
The ball is to the right, so that's positive, right? So that's going to be
Thanks, Riley.
25.
Yeah, but that's a cannon or the cannonball.
Oh, yeah. This is the cannon, right? Okay, so that should be 100. And this one we don't know. So you guys can do these. I know you can. The 25 is forward, so that's going to be like that, right? So VC prime is going to be minus 5 times 25, way to the left, divided by 100. Which is going to be, 5 times 25 is 125, it's going to be minus 1.25.
Now where the minus 5 come from?
This whole thing goes where?
You have to make sure it's
So then you should do. Yeah, shouldn't that 25?
Okay, let's do it this way. It's okay, you're not going to have to rewrite it.
Yeah, but it's negative 5.
Right? Plus 125?
Yes, yes. And you move it over to the other
Is that not the same thing?
side. No.
Thank you.
And you're making it 0 just because you know. that-
Because we know that they're at rest. Meters per second. Right? So these aren't hard.
So every explosion has that rest first,
Unless it states otherwise.
and then if it fails.
Then if it does, then you're going to have to actually do this on the left-hand side, right? Yeah.
That's just easy.
In fact, one could even argue that there's really no difference between collisions and explosions. It's just momentum before has to equal momentum after. Whether it's two objects colliding or an explosion that's moving or anything, it's all really the same thing. It's just a small variation.
Wait, so if we did this 10,
Probably not.
would you speak?
Probably not.
Why wouldn't you speak?
Would I speak? Sure, I'd speak.
Because if the camera was
I like to
What would
hear
you
them speak.
speak
I
about?
don't know. Well, it depends on what the theme would be.
We're given a theme.
Yeah.
Physics.
Actually, I'd so be into that.
I think he
I'm gonna see what I can do.
Also, science fair. I like. Yeah, science fair is cool. Yeah, I really want a science fair.
I have to tell you, this is
I
weird.
did a science fair once and it wasn't alright.
You're doing once in your life.
I done it once.
If you do a
Kaylee,
science
you need
fair,
to be-
then you do have to sign up. Yeah, you don't have to sign up. Yeah. What do you?
Anyways, as much as I love to debate the merits of science fairs, a firecracker is sitting on a tabletop. Right away, you realize at rest. It explodes into two pieces because it's a lousy firecracker. One is 100 grams, the other is 200. After the explosion, the first piece moves to the left at minus 1.2. How fast does the second piece move?
Oh, it's over there.
that is a tiny
I bet you guys can do this on your own already.
I bet you I can go
And it's like,
Do you? Do you need to have everything in kilograms? No. The only time you have to do that is when you're going to like another unit. Like if you were going like to acceleration or something rather, right? Like as long as you're keeping it, everything is grams, and it's all about a ratio. If you feel better about putting it in kilograms, go ahead. But it's going to be the same. Okay, so we got 0 on the left. So we got, this is just MAVA.
Is the first piece the 100 grams?
Yeah, that would have to be, right. Yeah.
fine.
So that would be 100 times minus 1.2. Like, these are easy. Are they not? Yeah, these aren't hard bad enough. Okay, so this time, you guys, I'm going to move that 100 times the minus 1.2, but I'm going to move it over to the left. And because I know that this positive times that negative is going to be negative here, it's going to go to the other side, it's going to be positive, right?
Yeah.
So it's going to be 100 times 1.2, right? And that's all going to be divided by 200. In fact, I probably should have left it on the right-hand side and moved the VB, I guess. But does it matter?
No.
Oh no.
This one I'm going to have to actually do my calculator. Oh, no, I'm not. 0.6?
Yeah, 125.
Oh, yeah, I guess it is. And that should be positive, right?
Yep.
Should we treat this as let's just treat it as a momentum question. Right? PI is PF. Let's just start with that. What makes up the momentum ahead of time? Oh, well,
But there's no.
there's no two pieces, but that's okay. It's just massive potato times velocity potato.
But I thought,
Does there have to be two pieces?
no.
That was no rule.
Because
It's a massive potato. It's a 6 kilogram potato. Like we're talking like a 15-pound potato.
Massive
Okay, but-
potato.
Oh, but it finishes with,
It finishes with two pieces. So we got 24 on the left. Now here's where, Danielle, if this is in kilograms, everything on the right has to be in kilograms, right?
That's what they're both in.
Yeah, so we're okay. So here let's go MAVA plus MBVB, those are primes. So two pieces, so that's 2 times 8, it looks like. Do I need to put the prime on the 8? No. The second piece, oh, it doesn't give me the size of the second piece.
well,
So I
what
should
is
do
it,
it.
lower? With mass and,
If the potato was 6 and one piece is.
Just subtract, right? It's a 6 kilogram potato. One piece is 2, so the other piece is going to be 4. Right? I threw you a curveball, but it's an easy one. Like, look at that's all it is. These one-dimensional ones are actually pretty simple. Yep. That's an 8. 2 times 8. Okay, so here we're going to have VB prime. I'm hustling because I really want to show you the Astro Blaster before we leave. You guys work that out.
what
What was that?
It's going to be 8. It's going to be 2, right?